Hello, welcome. I'm Richard Okoth. This week we have been applying decision trees and classification model e-learning data. And what we did, we loaded the data. I did some sanity checks, checking the first rows, checking data types, and also converted object data types to floats as a preparation of the data. Then we also checked the elements of duplicate, missing values, did statistical summaries, visualize the features, and use heatmap to see the correlations in the variables. After that, we did data processing, whereby we split the data into trend and test. Then we build a model, and the first model we built was a decision tree classifier. We built a decision tree classifier and we checked the confusion matrix, and from there we realized the decision tree was able to correctly classify the train data set, and we checked the features, importance, and the tree, and we realized our tree stopped growing at the depth of 2, and from there we did some tuning on the tree to be able to know the optimum parameters, and we used a grid search to search the best estimator, and we were able to get the best estimators with the maximum depth of 2, maximum leaf of 2, minimum impurity of 0.01, minimum leaf of 5, and our data was highly imbalanced, and we used to rectify this, we used the parameter class weight, so that at least to penalize misclassification of the minority class. And based on the we were able to check the tree. It's also stopped at the 2, and actually the most important feature in this case was SK2 classroom, which was important in this case. Then we also fitted the random forest classifier, and based on the random forest classifier was also able to correctly classify all the classes in the target approved. And we also did some tuning to determine the maximum depth, maximum features, and actually we used randomized search CV to find the best random forest estimators. And we did feature importance to determine the most important features importance, and from that SK2 classroom was the most important features, followed by SK1 classroom, then SK3, SK5, SK4, then creative post, and time online in that order. On the summary of the insight, we have been able to build a model to classify the data set. And as I said earlier, the data was imbalanced, and we used the class weight parameter to address this. We had the best decision tree had a maximum depth of 2, minimum leaf nodes of 2, minimum leaf sample of 5. It was able to correctly classify both trend and test with a performance of 100%, both in accuracy, recall, F1 scores. The important feature in the decision tree was SK2 classroom, which is creativity and innovation skill. And the decision tree rules was that whereby creativity and innovation skill was less or equals to 2.5, there was high likelihood of not being approved. While where creativity and innovation skills was greater than 2.5, there was high likelihood of approval. We also build random forest estimator, and the best estimator had maximum depth of 5, maximum features of 0.79, maximum sample of 0.7, and n estimator of 110. It was able also to correctly classify both train and the test with a performance of 100% in both scores. In terms of features importance, the most important features was creativity and innovation, followed by critical thinking and problem solving skills, followed by constant and self-learning, then social and cultural responsibility, followed by collaboration and self-direction, creative first, and time online in that month. Both decision tree and random forest had similar performance on the data. However, based on the depth of insight generated by random forest, it is more appropriate in this case. There is need to do further training of the model and test so that we can evaluate their performance. Thank you.